All right, we are on page 57 in our math book, and we're going to talk about complex ratios. So don't let the word complex scare you. All a complex ratio is if we pretty much have a fraction inside of a fraction. And then we're going to take it and we're going to change them into unit rates, which is just telling us how much for one of something. So like how many miles per hour, or how much money it is per one item. Okay, so let's take a look at this worked example. So traveling 1/3 of a mile in half of an hour represents a ratio of fractions for a complex ratio. It is also an example of a rate since the units, miles, and hours are different. So we can write this ratio as a complex ratio. We would be talking about miles per hour since we have a ratio, so we have to make sure it's set up in that order. So we would do 1/3 over 1/2. So it's just a fraction inside of a fraction. And so what is this rate in miles per hour? So in other words, we don't want to keep it like that. We want to simplify. So you have two ways. Remember that a fraction bar represents division. So we could rewrite it with the division symbol, and then we know from 6th grade how to divide fractions. So then we just keep change flip. Well, then we have 1/3 times 2 over 1, which gives us 2/3. The second method is that we can take whatever was in that denominator. So we can see down here it was 1/2. And since it was a denominator of 2, we can multiply by 2 over 2, which is just a value of 1. And so when we do that, we would multiply 2 by 1/3 and get 2/3, and then 2 times 1/2, and then that would simplify to 1. And so we would also get 2/3. So there are two different methods that you can choose to solve. Most people I've seen will choose method 1, but either will work. All right, so we're going to write each statement as a complex rate and then determine the unit rate. So we travel 1/4 of a mile in 2/3 of an hour. So first, we are talking about miles per hour. So that is the order we set it up in. Miles comes first, hours comes second. So it was 1/4 of a mile, so that is 1/4 over, and then the hours, which was 2/3. That is our complex ratio. Now we want to get the unit rate, so we want to figure out how much for one. In other words, how many miles can we go in 1 hour? So we can choose either method. I'm going to choose method 1. So I'm going to rewrite this. It's the same as 1/4 divided by 2/3. From here, we keep change flip. So we have 1/4 times 3 over 2. And now we multiply across our fractions. So we have 1 times 3, which is 3, and then 4 times 2, which is 8. So then our unit rate now is 3/8 miles per hour. All right, let's take a look at B. 1/2 inch of rain fell in 15 minutes. So we can do this rate in two different ways. We can do inches per minute, and that slash just meaning per. Or if we're talking about it in the real world, we can also do inches per hour, which typically when we're talking about rain, we're talking about how much it fell in an hour. So that's the one that we're going to do it in. But right now we have minutes. So minutes to hours. Well, there are 60 minutes in 1 hour. So if we were to do 15 divided by 60, and we simplify that, it would give us 1/4 of an hour. So that's what I'm going to use for my hours instead of 15 minutes. Okay, so let's set up our complex ratio first. So we are doing inches first. So it was 1/2 inch. So we're going to have 1/2 over, and then hours, which was 1/4. Then from there, I'm going to rewrite it with the division symbol. So 1/2 divided by 1/4. Then we keep change flip. So we have 1/2 times 4 over 1. Multiply it out. 1 times 4 gives us 4. 2 times 1 gives us 2. And then 4 divided by 2 gives us 2. So that unit rate would be 2 inches per hour. And so that's how much the rain fell in 1 hour. So that's the unit rate. Okay, Now we're going to flip over to page 59. Although the ostrich is the largest living bird, it is also the fastest runner. The table shows the distances that 4 birds ran and the amount of time it took each bird to run that distance. So we can see here's the 4 different birds, their different distances. Notice that they are in different units, as well as the time is in different increments of time. Okay, so each row in the table shows a rate. The rate for each bird in this situation is the distance covered per amount of time. So that means we don't have to worry about converting it to anything because it says we can just do it with whatever time we have. So distance per and then time. That tells us our order for our ratio. So let's do 5A. It says write the rate for each bird as a complex rate. So we are writing that complex ratio. Okay, well the distance goes first. So that was 22 miles. And then over the time, which in this case was half an hour. Notice I'm keeping the units on this one because when we change it to the unit rate in a second, I need to know how to label my answers since they're all different. So let's go ahead and take a look at 6. So you're going to write the rate for each bird as a unit rate. So that means we're going to take this complex ratio and actually solve it to get our answer. So I'm going to rewrite it using method 1. So we have 22 divided by 1/2. Then we're going to keep change flip. So we have 22 times 2/1, that reciprocal. Well, remember, even though we don't have 22 as a fraction, we can put 22/1 because that's the same as the number 22. And then now we multiply across. So 22 times 2 is 44. And then of course, 1 times 1 is just 1. So this simplifies to 44. And then our units were miles per hour. So we can just abbreviate that with the MPH. Okay, what you are going to do with your team is you are going to complete the rest of 5 and 6. So pause this video and then come back and check. All right, let's see how you did. So let's start first with 5. So for B, the greater roadrunner, it was 300 yards over half of a minute. For the quail, it was 20 yards over 2.5 seconds. And then for D, for the pheasant, it was 200 yards over 5/6 of a minute. All right, let's check your work. So here you have 300 divided by 1/2. So keep change flip to the reciprocal, and then we get 600. So that is 600 yards per minute. Remember that slash is per. For the quail, we have 20 divided by 2 1/2. So that's the same as 20 divided by 5/2. So I just changed that mixed number to the improper. And then we keep change flip. So 20 times 2/5. Remember, we could put that 20/1. So then we get 40/5, which simplifies to 8. So that final unit rate is 8 yards for 1 second. And then lastly, we have the pheasant. So 200 divided by 5/6, which is keep change flip. 200 times that reciprocal, 6/5. And so then we get 1,200/5, and that simplifies to 240. So the pheasant can travel 240 yards in 1 minute. So notice how fast these birds can actually travel. The ostrich is 44 miles in an hour. This one is 600 yards per minute. That is extremely far for 1 minute. And then 8 yards per second. That's even faster if you think about how long a yard is, so 3 feet. And so they're traveling that far in yards per second, and then 240 yards per minute. And so that is how our complex rate and our unit rates work.